Hello, Manikant. Hello. Can you hear me? Okay. So we'll wait for another maybe 2 or 3 minutes, then we'll start. Let's see if some people may also join. So we'll wait for some other people to join and then we'll start. Okay, I will start now. Good evening, all. My name is Ranjan Boda, and I am one of the TA in this course, which is the Biomechanics of Joints and Orthopedic Implants. And you all know that this course is instructed by Professor Sanjay Gupta from IIT Kharagpur. And today is the first tutorial session in which I will talk about some physics concepts from physics, and I will solve some problems, and I will solve the week 0 assignment, which was uploaded I think 2 weeks back. That was the prerequisite for this course. Like to understand this course properly, you need to know some concepts related to mechanical engineering, or let's it or from physics, which means those concepts you need to know beforehand to solve the problems related to this course. So I will start with those concepts today, and later on, like this tutorial session will be occurring on every Friday, same time, 6 to 8 p.m. You can join using the same link which was given for today. And yeah, so today is the first tutorial. Similarly, for all the 8 weeks, there will be the 8 tutorials. And I will be taking the tutorials. So if you want to cover me some concepts from the course from that week, means from the contents of the week, you can email me or you can ask me in this tutorial class. I will try to clear. I will try to understand, means explain those concepts to you, so that it will be easy for you to solving the assignment. And if you appear for the examination to get the certificate, then it will be easy for you to appear in the exam. So without any further delay, I will start now. I have already introduced myself. I am Ranjan Bora, and I am a PhD scholar at the Department of Mechanical Engineering in IIT Delhi. And my research area is also focused on related to biomechanics. That's why I am taking this course as a teaching assistant. So you can see these are the prerequisites which you should know beforehand before doing this course. Like you should know the concepts from force, then moment, then what is the equilibrium of rigid bodies, then concepts related to free body diagram, and then concepts related to friction. So I will cover each of these concepts today. I will explain the concept and then solve some numerical problems related to this concept. So it will be easy for you. So coming to the force, first concept, force, like what is a force? Like during our different daily activities, we act our body, like various forces act upon our body. Like this is one of the example. You can see a person is doing some exercise using his hand. So while doing this exercise, what are these arrow representing? These arrows are nothing but the force. So he is holding some weight. This force is acting in the downward direction. And similarly, in his hand, there are bones and there are muscles. So bone has some mass. This bone in which is in our forearm, this bone has mass, and this is the mass of the bone which is acting in at this point. And similarly, there is a joint here, like which is connecting the humerus bone and the radius and ulna bone. So because of the other external forces, there will be some reaction forces at this joint. So this joint reaction forces is acting in this direction, and we have the biceps muscles, and we all know that the muscles provide us the required force for our daily activities. So the muscle force will act in this direction. So this is one of the examples. Similarly, there are various examples. You can see these are the four scenario when a person is walking on the ground. Like you can see there is this while we walk, there is this reaction force which the ground act on our foot. Then similarly, similar to the biceps muscles, there are muscles there are muscles in our foot which help us in walking and in different activities. And these are the inertial force, means we have body weight which will act through the center of gravity of our body. And in the joint, you can see there are action reaction moments and action reaction forces. So in another example, a person is lifting some weight, and while lifting he tends to bend forward. So while bending forward, you can see this is the position which takes the person while lifting the weight. So you can see the weight of the body is acting to the CG of the upper body. This is the weight of the upper body. And here we have joint which connects the spine with the pelvis. And in this joint, there are some joint reaction forces. So these are some examples of forces which acts on our body during the different activities of our life. So like what is the definition of force? So definition of force is a force represents the action of one body on another and is generally characterized by its point of application, magnitude, and direction. So means force is a quantity which requires two body. Means on a single body there is no force acting. Like these forces on this hand is acting by this body, which is the dumbbell. So To act the force, we require two bodies. Means one gives the uh, action force, and another gives the reaction force. And one more point is force is a vector quantity. So what is a vector quantity? What is a vector? So I will explain next. So vector is a physical quantity which has both magnitude and direction. I think many of you have studied in your physics course in your high school, but since this is an interdisciplinary course, so there are people from various medical background also. So I will cover these concepts considering the people from all background. So example of vectors are, we have seen force is a vector quantity, then there is displacement, moment, couple, etc. And like we have seen some examples of various forces acting on our body, like the muscle force, joint reaction force, and the force due to the weight of the body. So if we want to find out the resultant force acting on our body because of all the force components, then we need to know some principles from vector geometry, from vector algebra. So this first principle from vector algebra is addition of vectors. Like vector is not like a scalar quantity. We have scalar quantity which are like numbers. Means some example of scalar quantity are speed, then mass, then distance. Those quantity to means to do for evaluating the resultant of those quantity, we don't need any law. But for evaluating the resultant of some vector quantity, we need some law, some theorem from vector algebra. So one of the law is addition of vectors, in which we apply the parallelogram law. That means if there are two vectors acting like acting at a point, and they are directing in their directions are as shown in here, and then the resultant of these two vectors can be given by this blue colored line. This is which is given by p plus q. Direction is given by this, and there is one formula for evaluating the magnitude. But if there are two vectors perpendicular to each other, p and q, then their resultant will be at an angle of 45 degree, and this resultant magnitude of this resultant will be square root of p square plus q square. This condition is when the forces are at an angle of 90 degree. But when the forces are at an angle of theta, then we have another formula which I will explain in my next class and in my later class. So this is a simple case in which we can apply this formula for evaluating the resultant of two vectors acting at a single point. So till now, is this clear for you? Are you able to understand? If you have any doubt, you can ask, or if you don't understand anything. So is it clear till now? Okay, good. So next, there is one problem. Like you can see, this is the simply partial knee joint. Means we are considering only two bones on the knee, and in this is the patella, which we call patella. And forces acting on the patella are This force is Fp and this force is Fq. So we need to find the resultant force Fr on the patella due to the forces applied by the quadriceps and the patellar tendon. So Fq is, let us take as 400 Newton and Fp is 300 Newton. So can you find out the resultant force? Resultant magnitude of the resultant force Fr. If you have understood the concepts which I taught previously today, then you can solve this problem. This is a simple problem. There are two vectors which are acting at an angle of 90 degree, and their magnitudes are given 400 Newton, and this is the 300 Newton. So you need to find the resultant. Are you guys solving? Yes, it is 500 Newton. So I will show this is a simple problem. These forces are at an angle of 90 degree. So the resultant R, the magnitude of resultant R will be square root of 400 square plus 300 square. So it will be 400 square is, and 300 square will be, so it would be 250,000, 500. So the answer is 500 Newton. So this kind of problem you will get in your assignment, assignment in the next upcoming weeks. Next, one more concept is the rectangular components of a force. Means a force can be resolved into two components which are perpendicular to each other. You can see it in this figure. There is one force F which is acting in this direction at an angle theta from the x-axis. So we can resolve this force into two components along the x and y axis. So here the x component is Fx and y component is Fy. Now what is the magnitude of this x component? This magnitude of this x component is Fx equal to F cos theta, and magnitude of y component is Fy equal to F sin theta. So if you know the value of theta and F is given, then you can find out the two rectangular components of this force along the x and y axis. So next, one more concept is unit vectors. What are the unit vectors? Unit vectors are of unit magnitude and they are directed respectively along the positive x and y axis. These vectors are denoted by bold I and J, or I cap and J cap. One cap sign is there above I. That's why it is called I cap. And you can see here in this figure, these are two unit vectors. Along the x-axis, we represent it with I, and along the y-axis, we represent it with J. And their magnitude is 1. And where they are used, they are unit vectors are used to express this force F in terms of Fx and Fy. You can see this like Fx component we can write as Fx into I cap, and Fy component we can write as Fy into J cap. So the final force expression can be written as Fx I cap plus Fy J cap. What is Fx? Fx is the magnitude. Magnitude can be given using F cos theta. And what is Fy? Fy is the magnitude. Magnitude is given using F sin theta. And what are these I and J? These are the directions. These are representing the direction. Next, there is one more problem related to this rectangular components of force along the x and y. So please try to solve it. If you can, then I will help you solving the problem. There are two forces P and Q acting on a bolt A, and we need to find the resultant of those forces. Force magnitudes are given and angles are given. Along this is the x, and along this is the y. Please try to solve it. Anyone solved it? Okay, I will do it. Here you can see there are two forces. One is 40 Newton and another is 60 Newton. 40 Newton force is at an angle of 20 degree from the x-axis, and 60 Newton force is at an angle of 25 plus 20, which will be 45 degree from the x-axis. So we can draw these forces separately. So this force is P, which is at an angle of 20 degree, and Q force is at an angle of 45 degree. So we need to find out the components, X components and Y components of these two forces. So the component Px will be P cos theta, which we have seen earlier today. P is given 40, cos theta is 20. So Px will be 40 cos 20 and Py will be 40 sin 20. And similarly, Qx will be Q is 60, 60 cos 45, and Qy will be 60 sin 45. So we have got the components, x components and y components of these individual forces. Now what we need to do, we need to add these components. Like we'll add these two components in the x direction and two components in the y direction to get the resultant component in x and y direction. So resultant component fx will be px plus qx, which will I will calculate, and resultant component fy will be py plus qy. How much is fx? Have you done the calculations? So fx is 80.01 and fy is 56.11. So the resultant will be f resultant will be square root of fx square plus fy square. Why we are writing like this? Because fx is along the x axis and fy is along the y axis. So we have already seen, if two forces act at an angle of 90 degree, then their resultant is given by this formula. So here we'll put fx 80 square plus 56.11 square. It will be the resultant is 97.71 Newton. Okay, has anyone solved this? If you have any doubt, you can ask. If you haven't understood it, then you can ask me. Yes, yes. Ramya, your approach is also right. We can use that formula also. That formula you used in one case I showed when two vectors are acting at an angle theta. You have applied that formula. This formula you have applied. The resultant will be this resultant is given by that formula which you have used. So yeah, you can use that formula also. No problem. Okay. To we have seen force. Now we'll see what is the moment. So moment is nothing but when a force acts on a body, then the moment is the tendency to movement. Means the force tries to produce some movement of the body. Like in this example, you can see there is a body, and O is the center of gravity of the body. Now, if a force is acting at this point A at a distance of r, so I will draw it here. So this force F is acting at a distance r from the CG of the body. Now, because of this force F tries to rotate the body uh, about this axis in this direction, the direction I have shown here. So, what is the magnitude? This means this tendency to rotation, we call it is a moment. And what is the definition? Moment of F about O is the vector product of R and F. So we have seen that force is a vector quantity, and this R is a vector quantity. So moment is a cross product of two vectors. So moment is also a vector quantity because R is a vector quantity and force is a vector quantity. And how? So here comes the vector product of two vectors or cross product of two vectors. You can see there are two vectors P and Q lying on a plane at an angle theta. And now this cross product P cross Q, what this cross product represent? Uh, this this cross product means magnitude of this cross product is given by this PQ sine theta, and the line of action of V is perpendicular to the plane containing P and Q. And the direction of V is obtained from the right hand rule. That means in the right hand rule, we place our fingers along this axis P, means fingers of our right hand. So if this is our right hand, we place our fingers along this P axis, then we curl our fingers along the other vector Q. So the direction of the thumb will give the direction of the direction of this moment V. So what is the direction of this thumb in this case? The thumb is representing in the upward direction. So direction of moment V is in the upward direction. So this is how we find out the direction of a moment. So we have already seen like m is equal to r cross f, and this magnitude of m is given by rf sine theta, and we can also write it as f into d. What is d here? D is r sine theta. In this triangle, if you see, this angle is theta, and this angle is, so I'm drawing it here. This angle is theta, and this is r, and this distance d is r sine theta, because this is r cos theta, and this d is r sine theta. Okay, so next comes couple. What is a couple? Couple is when two forces of equal magnitude act in the means parallel to each other and in the opposite direction, then they form a couple. In this figure, you can see there are two forces of magnitude f. They are acting parallel to each other and in the opposite direction. So these two, we can say these two forms a couple. And how we determine the magnitude of this couple? The magnitude we determined again the vector algebra, like we take a origin point O, and then we find out the resultant moment of because of these two forces. So what is the moment about O? Since there are two forces, Fn minus F, and F force is acting at a distance of Ra. So moment about O because of this force F is Ra cross F. Then this minus F force is acting at a distance of Rb from point O. So moment about O will be Rb cross minus F. Now, if we do this algebra, means if we add these two vectors, then we will get we take out the F common, and we'll get Ra minus Rb cross F. And again, what is Ra minus Rb? Ra minus Rb is equal to R. Again, this is coming from the vector algebra, like this is Ra, and R is acting in this direction, and this is Rb. So using the vector algebra, we can write R equal to Ra minus Rb. This law is simply the addition of two vectors. So we can write the moment of this moment because of this couple as m equal to r cross f, then rf sine theta, and same using the f into d. What is d? D is the perpendicular distance between the two forces. This is the d. So if we represent it here, d will be distance between perpendicular distance between the two forces. Okay, so since I have already covered some concepts from moment and force, now we will solve the assignment from week 0, which was given to you. Can you tell me what is this answer for this first question? What does the moment of the force measure? You can write your answer in the chat box, like A, B, C, or D. Write like that. Yeah, Sabari, do you have any doubt?
Yeah, my chat option is not available.
Okay. Okay, you can then speak out, no problem.
Option A,
Yes,
tendency of rotation.
yes, option A is correct. So what is the explanation? Explanation is like the moment of the force measures the tendency of the rotation of the body along any axis, whether it be the centroid axis of the body or any of the outside axis. Next question. The moment of the force is the product of the force and the perpendicular distance to the line of action of the force. This is a true or false. So this is a true statement we have seen in our class today. Like the moment is the product of the force applied to the body and the perpendicular distance of the line of action of the force about which the body is being rotated. And the next question is the moment axis force and the perpendicular distance in the moment of the force calculation is lying in. What is your option? The option A is correct. Like here, the moment axis force and perpendicular distance in the moment of the force, they lies on two planes perpendicular to each other. You can see the explanation: moment axis force and perpendicular distance lying in the three-dimensional Cartesian. It doesn't lie on the single plane. It also doesn't lie in a single line. Next question is which of the following is true? Four options are given. Yeah, option A is correct. Total moment of various forces acting on the body is the vector sum of all moments. And what is the explanation? The moment is a vector quantity, as the value of the total moment caused by various forces acting on the body is the vector sum of all the vectors. Next is the couple is a scalar quantity and the force is a vector quantity. We have seen today what is a couple and what is a force. So we know that couple is also a vector quantity and force is a vector quantity. So this first statement is false and the other part is true. And next question related to moment is larger the moment term, the greater will be the. So we have seen what is a moment. Moment is given by R cross F. And what is R? R is the moment term. So if this R is more, uh, if this R is more, then yeah, larger, the greater will be the moment. So D is correct. Okay, next concept I will speak about is the equilibrium of rigid bodies. So what does the equilibrium of rigid bodies mean? So means for a body to remain in equilibrium, there are some conditions which the body need to satisfy. Then only it can remain in equilibrium. So those conditions are summation of force, means summation of all the forces acting on the body should be equal to 0. There should be no resultant force acting on the body if the body should remain in equilibrium. For example, here is a body. If a force of 100 Newton is acting in this body, then now is the body is in equilibrium? Is this body is in equilibrium at this condition?
No.
Yeah, it is not in equilibrium because there are resultant of 100 Newton force in the vertically upward direction. So to balance out this 100 Newton equilibrium, means 100 Newton force, there should be one extra force which should act in the vertically downward, means of the same magnitude, 100 Newton. But here again, means if we consider this as the CG, center of gravity of this body, then again their momentum is different. So this condition is in force equilibrium, but this is not in the moment equilibrium for this body in this state. So means to for a body to remain in equilibrium, it should satisfy both these two conditions. Summation of force should be 0 and summation of moment should be 0. Then only we can say this body is in equilibrium. So for this body to remain in equilibrium, what do we need to do? We need to let's assume this is 10 centimeter and this is 5 centimeter. So what we need to do, we need to translate this force up to this point, up to this 10 centimeter. 10 centimeter. So yeah, now this body is in equilibrium. Initially it was 10 centimeter. Sorry, initially it was 5 centimeter. So now this body is in equilibrium, both the force equilibrium and both the moment equilibrium. Next, there is one theorem which is known as Lami's theorem, and it why we use the Lami's theorem. We use the Lami's theorem when there are three forces acting at a point, three concurrent forces acting at a point, and they are in equilibrium. Then there is one relation which we can write, means using this force magnitude and the angles between them. So if we consider the angle between force B and C is alpha, then C and A is beta and B and A is gamma. Then there is one relation. This is the relation. We can write this A divided by sine alpha equal to B divided by sine beta equal to C divided by sine gamma. So later we can use this relation for solving our numerical problems in the upcoming weeks. Means when there will be problem related to different joints. So we can use this theorem to solve the numerical problem. So there is one question related to the Lami's theorem, which is Lami's theorem is applicable for. So what is the option? So we have seen in the previous slide, this Lami's theorem is applicable for concurrent and coplanar. Next concept is free body diagram. What is a free body diagram? So in free body diagram, we isolate the body of our interest and represent all the forces acting on it. That means you can consider this means this condition, this situation of the hand in which a person is doing lifting some weight of 80 Newton on his hand. Then if we are interested to draw the free body diagram in this for this in this condition, then how to draw it? So let's assume we want to draw free body diagram for this 80 Newton block. So we will isolate this 80 Newton block. We'll draw this 80 Newton block, and what are the forces acting on it? Like there are the force due to force because of its weight, which is 80 Newton. And since this block is holding means is supporting on the hand, so there will be one reaction force which will act on this block because of the from the support of the hand. So we can say these reaction forces are. So these are the two forces which will act on this block. Means if we isolate this block. Now, if we want to draw the free body diagram for this complete hand, for this hand, so how we will draw? We will then separate out separate out the hand. Then we will not draw the block because now we are interested in drawing free body diagram for this hand. So in the hand, what are the forces acting? There is one force of 80 Newton, which is acting in this vertically downward direction. And in the CG, here is one force, which is the weight of this hand, W. Then since there is one flexor muscle, there will be one muscle force, Fm. Then since there is one joint, there will be one reaction force in the joint, which will be Fj. So this is the free body diagram for this end. So is it clear? Anyone have any doubt? Later, for solving the problems, you need to first draw the free body diagram. Then you need to draw the various forces which are acting on the body. Then only you can then you will apply those equilibrium conditions. Then you can solve for the unknown. Means what it is, what you need to find out. You can solve those problems. Similar means first step is to draw the free body diagram. Is there any doubt here? Is it clear how to draw the free body diagram? If you have any doubt, you can ask. Okay, I will assume that you have understood it. So there was one question related to free body diagram. Uh, it is asking what is a collinear system of forces for free body diagrams. So what is the option? What does this collinear means? Collinear system of forces. Yes, C option is correct. Collinear means all the forces acting along the same line. Now there is one problem you need to solve. Like in this problem, a person standing on a uniform horizontal beam that is resting on frictionless knife edge and roller supports, and be 2 points where the knife edge and roller supports contact the beam. C is the center of gravity of the beam, and D is the point on the beam directly under the center of gravity of the person. Now the length of the beam is given, which is 5 meter, and the distance between points A and D is 3 meter. The weight of the beam is 900 Newton, and the mass of the person is 60 kg. You need to calculate the reactions on the beam at points A and B. So first step is to draw the free body diagram. So how to solve this problem? So first we need to draw the free body diagram of this beam, which is given. Uh, Means these A and B are the supports. So what are the forces that will act on this support? There will be reaction force in the upward direction. Here it will be FA, and here it will be FB. And at point C is the CG of the beam. And so the force that will act on C will be the weight of the beam, which is given 900, 900 Newton. And at point D, through the point D, the weight of the person will be acting. Uh, Mass is given 60 kg. How to find the weight of the person? Weight of the person will be 60 multiplied by this acceleration due to gravity, which is 9.8 Newton. So it will be 588 Newton. So 588 Newton force will be acting at the point D. And what are these distances? This distance is given 3 meter, and L is given 5 meter. So you got the free body diagram. So now you can apply those equilibrium conditions for solving the problem. This is the free body diagram. What are the equilibrium conditions you will apply? Like summation of force in the y direction should be 0. And this will give us one equation, and summation of moment about the point A will be 0. Because this system is in equilibrium, that's why we are using these two equations. So what it will give us? The first equation, it will give FA plus FB equal to 900 plus 588. It will be FA plus FB 1488. And what will be the second equation give? Summation about MA equal to 0. It will give, we'll take moment about this point A. This is the point A. So about this point, what are the moments? Like this 900 Newton is acting at a distance of 2.5 meter because it is the center of gravity of the beam. So it will be the midpoint of the length midpoint of the length between the A and B. So it will be 2.5, and 580 Newton is acting at a distance of 3 meter, and this FB is acting at a distance of 5 meter. Next, we'll take this clockwise direction as positive. So we'll in using this moment equilibrium equation, what we'll get this 900 multiplied by 2.5 plus 588 multiplied by 3. FB is acting in the anticlockwise, so it will be minus 9 multiplied by 5 equal to 0. So if we solve this, then we'll get FB. FB will be how much? FB is 802.8 Newton. So we have find out FB. Now we can substitute FB in this equation, then we will find out the FA. FA will be how much? FA will be 1488 minus 802.8. It will be 685.2 Newton. So this is how you can solve the problems using this equilibrium conditions. I hope it is clear to you. So there is one more problem. This you can try to solve it by yourself. This is the scenario which we have, which I have already drawn. I have already showed to you how to draw the free body diagram. So you can easily draw the free body diagram now, and then you can apply those force equilibrium and moment equilibrium condition. Then you will find out what it is asking in the question. Like we need to find out the force required in the flexor muscle and the force in the humerus against the ulna to support the load neglecting friction. Then give it a try. So want. First, draw the free body diagram of the hand. Okay, so we need to isolate the hand. So at this point, 80 Newton will act, and at this point, CZ, through the CZ, the weight. How much it is the weight? Weight is given 20 Newton. So 20 Newton will act through this point. And what are the other two forces? One force will be the force in the flexor muscle, which will be Fm, and one force will be the joint reaction force because of this because of this ulna bone to the humerus bone. So it will be Fj. Now we don't know the directions. We are assuming that Fj will act in the vertically upward direction. And while after doing the calculation, means if it comes positive, then our assumption will be correct. But if it comes negative, then our assumption will be wrong, and means the Fj will actually acting in the downward direction. So after calculation only, we will get to know the actual direction of Fj. Initially, we need to assume one direction for Fj. Now, what are the conditions we will apply? Same like summation of Fy is 0 and summation about M. Let us take this point as J. M about J is 0. And these distance are already given. This is 40 mm and this is 105 mm and this is 370. Now try to solve it. I think you can do it now. So how to solve it? Using the first equation, summation of Fy equal to 0, what we will get? We will get this Fj and Fm are acting in the vertically upward. So here it will come Fj plus Fm equal to 20 plus 80. It will be 100. So we have got one equation, and what will be the second equation? So in the second equation, we'll assume the moment about this point J. Summation of the moment about the point J is 0. So Fm, again, we'll assume this direction, clockwise direction as positive. So Fm is producing moment in the anti-clockwise direction. So it will be negative minus Fm into 40. Then 20 Newton is producing moment in the clockwise direction plus 20.105 and plus 80 Newton is again producing in the clockwise direction. So 80.370 equal to 0. So if we solve this equation, we will find out Fm. How much will be the Fm? So Fm is 792.5 Newton. So now you can use this equation 1. What equation 1 will give us? Equation 1 will give us Fj will be 100 minus 792.5 So it will be minus 692.5. So what does this minus sign represent? That our assumption of direction of FJ in the vertically upward is not correct. In actual scenario, the FJ will act in the downward direction. So uh, actual direction of FJ will be in the vertically downward direction. Okay, now again we will solve. I think it is clear to you. If you have any doubt, you can ask. Okay, we'll move on. Next, this was the question from assignment 0, means assignment which was uploaded in week 0. So in this question, it is asking the principle of transmissibility for free body diagrams. What does this represent, the principle of transmissibility? What is the answer? So your answer is A. Means principle of transmissibility means and states that the force acting on a body is a sliding vector, and means the state of rest or of motion of a rigid body is unaltered if a force acting on the body is replaced by another force of the same magnitude and direction acting anywhere on the body along the same line of action of the applied force. Means uh, if there is a body and force F is acting in this direction, now this will be the line of action of this force F. So if we translate this force F means along this line of action, so it may act at this point or at this point or at any point along this line of action, then the state of the body remains unaltered. Means if the body is in rest, it will remain in rest. If the body is in motion, it will remain in motion. So that so principle of transmissibility means that means we can slide this force along this line of action to any point on the body. Okay, next question. For stability of equilibrium configuration, the net for force acting on the body is 0. It is a true statement we have seen. This is the condition for equilibrium. And similarly, the net moment should also be 0 for the body to remain in equilibrium. And next question, the point through which the entire weight of a body acts is called the, any answer?
Center of gravity.
Yeah, center of gravity is right. And what does this center of mass is? Center of mass of a body is defined as a point at which the whole of the mass of the body or all the masses of a system of a particle appear to be concentrated. So if there are masses in a reference system, then what will be the center of mass? Center of mass will be the point at which all these masses are concentrating, means all these masses will appear to be concentrated. This point is called center of mass. And the point through which the weight of the body will act, that point is known as center of gravity. This is center of mass, and if the weight is acting through this point, then this point is also known as center of gravity. Next, one more concept was friction. Like, what is a friction? So the definition of friction is when two surfaces are in contact, then uh, these frictional forces will always develop if one attempts to move one surface with respect to the other. So this example you can see, like in this first case, case one, this body is resting on this surface. At this condition, there is no frictional force because there is no tendency of movement of any body with respect to the other body. But if we start applying some force P in the second case, you can see in case two, we start applying some force P, then only this frictional force will get developed. If there is no force P, then there is no frictional force. So frictional force only appears when there is a tendency of movement between the two bodies. And how we can give the relation of the frictional force with respect to the applied load. So you can see here F is the frictional force and P is the applying load. So at the point when P is 0, frictional force is 0. Means there is no P, there is no frictional force. But when we start increasing the force P, you can see the frictional force is also increasing in the linear fashion, means in a linear trend with P. And there will be one point at which the frictional force will be maximum. And after that, means when this force P overcomes the friction from the ground, then it will start moving the body. Then the body will be in motion. Up to this point Fm, this body is in equilibrium. After this point Fm, means after this force Fm has been reached, the body will start moving. And in that when the body starts moving, this force Fm slightly gets reduced, then it will remain constant for the whole movement of whole motion of the body. And this Fk is known as kinetic friction. This Fm is known as static friction. So what is a static friction? Like we have seen, maximum static friction force is given by mu s multiplied by n. What is n? N is the normal reaction force. Means the reaction force from the ground, normal force acting by the ground on this body. And mu s is the coefficient of static friction. Now, when the body is in motion, in that case, the frictional force, we call it as kinetic friction. And how this kinetic friction force is given by mu k into n, where mu k is the coefficient of kinetic friction. So I think it is clear to you what is a friction and what are two different types of friction. One is static and one is kinetic. Static is when the body is in rest condition and when there is a tendency of movement of one body with respect to other. And kinetic friction is when the body is in motion condition. Body is moving with respect to the other body. This is the question from the assignment 0. like the maximum value of the frictional force is called what is your answer? The maximum value is called as limiting static friction. We have seen in the previous slide. And next, if a body in equilibrium condition is acted by three forces, then the line of action of these forces would be so the line of action should be either concurrent or parallel. And next question is cantilever beam has one fixed end and other. So what is a cantilever beam? Cantilever beam means looks like this. Means one end is free and other end is fixed. This is the fixed end and this is the free end. Okay, next question. Indeterminate structures have a number of unknown quantities. There's available conditions of equilibrium. What does these indeterminate structures mean? So indeterminate structures have number of unknown quantities more than the available conditions of equilibrium. And what is a statically determinate structure? Is the one in which reactions and internal forces can be determined from free body diagrams and equations of equilibrium. So I'm giving you an example of statically determinate structure. If this is a beam and means this beam is supported onto supports and there is one force of 100 Newton. So here this is a case of statically determinate because here how many unknowns we have? If we draw the free body diagram of this beam, how the free body diagram will look? There will be 100 Newton and there will be FA, there will be FB. So there are two unknown forces, reaction forces, FA and FB. And how many equations we have? We have the equilibrium of summation of Fy is 0 and summation of M about A is 0. So if we apply these two forces, sorry, these two equations, then we can find out this unknown quantities Fa and Fb. So here we have two unknown quantities and two equilibrium conditions we have. So this is a condition of statically determinate. This is statically determinate. So means if we here in this structure, if we get one more unknown, then there we'll have three unknowns, and but we'll only have two equilibrium conditions. So that condition will be known as statically indeterminate, where the number of unknown quantities are more than the number of available equilibrium conditions. One question was the center of mass of a system of particles. So I have shown you like center of mass coincides with the center of gravity in a uniform gravitational field. If the gravitational field is not uniform, then it doesn't coincide. And next question is, a free body diagram is a sketch of an object of interest with all the surrounding objects stripped away and all of the forces upon the body. So it is a true statement. We have seen it. Next question. Static friction is recognized as a self-adjusting force because it wants the objects to remain at rest. Is this true or false? We have seen it. This is a true statement because when we start applying some force, then only static friction appears. And what does it do? It tries to restrict the motion. And force acting on a body may retard its motion or change its motion or balances other forces acting upon the body. So all the conditions are correct. Next question is, speed of sound in air is approximately equal to, option B is correct, 340 meter per second. And speed of light is option A, 3 into 10 to the power 8 meter per second. So these were all about the prerequisite concepts which are required to understand this course. Now we'll start some content from week 1. I think you have already gone through the video lectures from week 1 because next week you need to submit, means the deadline for submission of week 1 assignment is next Wednesday. So go through the videos and then you will be able to submit the assignment. So I will cover some basic concepts from week 1. Like in the week 1, the contents are related to about musculoskeletal system. So what is a musculoskeletal system? The musculoskeletal system consists of bone, joints, muscles, tendon, and ligament. And means how we for solving any numerical problems related to any musculoskeletal analysis, we need to first model these anatomical elements which are present in our body. So how we model our bones? We model our bones using some rigid links, and we model joints using the standard joints, and we model muscle plus tendon as actuators, and we model the ligament as controllers and springs. And next is joints. So what is a joint? Means joint is a site where two or more bones meet, and joints can be classified based upon their functions. The main function of a joint is to allow the movement, allow the degrees of freedom of, so that we can move our body or we can perform our daily activities. So based on this functional classification, joints can be classified as synarthrosis, amphiarthrosis, or diarthrosis. What is a synarthrosis joint? It is an immovable joint which is present in our skull in the form of suture, and amphiarthrosis is slightly movable joint. It is present in our hand between the radius and ulna. And diarthrosis means fully movable joints, which is present in hip, knee, hip and knee are two examples of diarthrosis joint. So classification of joints based on the structural means the material binding of the bone, So one classification is known as fibrous joint, bone ends united by the collagenous fibers. In this also there are three classifications, and one joint is known as cartilaginous joint, where bones are united by cartilage. There are two types, synchondrosis and symphysis. And one is of a synovial joint, where bones are united within a fibrous joint capsule. So what is a synovial joint? Like in the human body, you can see different types of synovial joint present in our body. Like this is the ball and socket joint, which is the hip joint, and in our hand, in our wrist, there is this condyloid joint between the radius and carpal bones, and in our ankle, there is the plane joint between the tarsal bones, and in our hand, the elbow joint is a type of hinge joint. So these are the types of synovial joints, which are planar joint, hinge joint, pivot joint, saddle joint, ball and socket joint, condyloid or ellipsoid joint. Now, these joints can be modeled using some mechanical elements, like the muscles and ligaments can be modeled as if using either cables or ropes, and similarly muscles can be modeled using two force members, and this bone-to-bone contact can be modeled using these rollers and other simple supports. Like you can see here, we can model this bone-to-bone joint contact as some roller joint, and elbow joint is a type of hinge joint, which we have seen in the previous slide, and hip joint we can model using the ball and socket joint, and skull, in the skull we have this temporomandibular joint here. How we can model this temporomandibular joint? We can model the temporomandibular joint as a hinge or fixed and welded joint. So means for simplification purpose, we model the defined biomechanical elements using equivalent some mechanical elements, so that we can solve the problems related to biomechanics. So this modeling approach will be useful, means, and will be also be discussed in your upcoming weeks. So that was all for today. Thank you for joining. If you have any queries or any suggestions, you can tell me. And next class will be on next Friday at the same time. You can join using the same link. And if you have any doubts or any suggestions, any feedbacks, you can just email me in this my mail ID. If you want to cover me some concept which you don't understand from the week content, then you can mail me, but mail me before, means 1 or 2 days before the next tutorial, which will be on 29 September. So if you have any queries, you can ask me. Or how did you find today's lecture? You can tell me. Yeah, the assignment you can submit, means in the NPTEL portal itself. Means there is one MCQ type assignment only. So in that assignment, you need to select all the options, means all the correct options for those questions, and then in the bottom of the page you will find the submit button. So if you click the submit button, then the assignment will be submitted. For these tutorials, there are no assignments. Means these tutorials, I will solve some problems in the tutorial itself, and but no assignment for these tutorials. Okay, so I hope you were able to understand what I taught today. So is it clear? Like you were able to understand, or you didn't understand the concepts which I discussed today? Okay, thank you. Okay, then if you have no queries, then you can leave. I will end the call now.